Acids and bases. One of the most important aspects of a living system is the degree of acidity or alkalinity that it has. Alkaline is just another word for basic, which is what you can think of as just the opposite of being acidic. So we'll look at acids first. An acid is a substance that releases hydrogen ions, H+. And so I want you to be able to look at an equation like this. You don't need to know that's an acid, except if I show you the equation, here's the arrow, and so the products, one of the products, is this hydrogen ion. So because it's releasing hydrogen, and you've memorized that acids release hydrogen, now you can tell me that that's an acid. So I would want to be able to show you this equation, and I would want you to identify that as an acid. Here's another example. H2SO4. Pretend that looks like H2SO4. I don't want you to memorize that that's sulfuric acid. Here's what I want you to know. If I give you an equation where that releases a hydrogen ion plus HSO4 minus, I would want you to say, oh, look at that's a hydrogen ion. Oh, I memorized that acids release hydrogen. Oh, so this thing here must be an acid. If you look at, let's see, H2, whoops, I already messed this up. H2CO3. Is that an acid? Well, if I draw this out for you, I don't expect you to be able to draw it out, but if I draw out this and I give you an H+, and the bicarbonate ion is CO3 minus. If I gave that to you, I would want you to say, oh, look at that, it's a hydrogen ion. This thing must be an acid. It's carbonic acid. So I would want you to know that that's an acid. I certainly don't want you to know what kind. So that's what I want you to know about acids. The more H pluses you have, the more acidic it is. So if you have some water here and you've got a lot of H pluses around, then that's an acid. If you had pure water and let's say you got rid of all this stuff, if you had pure water and there was just pure water, nothing else, you'd have some H's and you'd have some OH's, and that would be it, and that would be totally neutral. The more H's you have, the more acidic it is. Bases are the opposite. So I'm going to define a base for us as a substance that releases an OH, so hydroxide ion. So this, for example, I wouldn't necessarily need you to know it's sodium hydroxide, but if you're releasing this thing, OH minus, I would want you to say, oh gosh, that must be a base, because I remember that I had to memorize that a base releases OH. And look, there's an OH, that thing must be a base. So an example again of an acid is one that releases this H+. An example of a base for our purposes is something that releases OH minus. So here's my base, here's my acid. Acids and bases can neutralize each other. So something really strongly acidic can burn you and something really strongly basic can hurt you as well. Take a look at this. Hydrochloric acid releases H+. So that's this. Sodium hydroxide releases OH minus. So that's this. H plus and OH minus, you put together, you've got two H's and an O. That's water. Nothing's more neutral than water. So this is another really important thing about acids and bases. If you have something acidic, it can be neutralized by a base. So for example, anyone who's thrown up can tell you that throw up feels gross. So vomit is just disgusting. And what's happening is that it's burning your throat on the way out, which is why you want to drink water or brush your teeth and get that taste out of your mouth. So you typically, this is going to be a little bit gross, but typically you don't feel acid on the way out. So in other words, here's your mouth and your esophagus. That's a really bad esophagus. Let's do it up here. Here's your mouth. I'm going to try to make this nice. Here's your esophagus and your stomach. And of course, your stomach is where the acid is. So you've got this HCl And that's the stuff, whoops, sorry. That's the stuff that's in your stomach. And after your stomach comes your small intestine. And the small intestine isn't really small. It does have a small diameter, but it's actually really, really, really long. And it's wound up inside of you, and you're pretending that I'm drawing a nice, good, long coil. And then you've got your large intestine, which isn't really larger, but it's not longer, but it is wider. And so that wiggles around this way and down to where you poop your stuff out. So you know that your stomach is acidic because when you puke, you can feel the acid coming out this way. But by the time the food gets all the way through here and you poop it out, it doesn't feel like acid anymore. And if it goes through too fast, actually, the diarrhea will feel acidic. So you know somehow it's gotten neutralized between your stomach and by the time you poop it out. And the thing that happens is that you've got a pancreas sitting about here that releases, guess what, into here? You're right, releases some type of a base, bicarbonate ion actually, releases a base into here, and that neutralizes the acid. Cool, huh? Okay, so what you need to know for MCAS is the pH scale. And pH, this is the percentage of hydrogens there are. So the scale goes from 0 to 14, and it's logarithmic, and so it's weird, but the lowest numbers, it's 10 to the negative whatever, the lowest numbers actually have the most H's in them. So memorize that neutral is 7, and that 0 to 7 is acidic, and that anything greater than 7, so 0 to less than 7 is acidic, anything greater than 7 is, well, 7 to 14 is basic. So here's your pH scale. Right in the middle is 7. A, B, C, D. Oh, A. A comes first. A's are acidic, so they are from 0 to 7. B's come second. They are from 7 to 14. So a pH of 1 is acidic, a pH of 2 is acidic, and so on up until almost at 7. 7 is going to be neutral. Here's the crazy part. What's more acidic, pH 1 or pH 6? They are both acids, but pH 1 is going to be a stronger acid. So anything away from 7 is a stronger acid. Anything away from 7 is a stronger base. So a pH, let's say, of 8, is that an acid or a base? Well, it's on the base side, so it's a base. But it's so close to neutral, it's practically neutral. It's a very, very weak base. So the stuff that's close to 7 is weak, whether it's an acid or a base. I'm supposed to say weak. And the stuff that's out here is really strong. So a pH, let's say, of 13 is a super, super strong base. So not only do you have to know what's an acid and what's a base, but you need to know what's a weak acid or base and then what's a strong acid or base. So again, a pH of 1 is a really strong acid. pH of 6.5, it's still an acid because it's smaller than 7, but that would be a really weak acid because it's so close to 7. A pH of 9, still a pretty weak base, especially compared to like a pH of 13. That would be a really strong base because it's very far removed from 7. The lower the pH, the stronger the acid. So acids are things like vinegar and lemons and lime and puke. The higher the pH, the stronger the base. And so these are things like oven cleaner and Drano and baking soda and Tums so that you don't have an acidic stomach. pH 7 is neutral. So here's your pH scale again. 7 is neutral. Black coffee here at 5. Apple juice at 3. Stomach acid down at 2. Battery acid at 0. Don't memorize any of this stuff. An antacid pH 8. Baking soda 9. Hand soap 10. This is just to kind of give you an idea of what things you know that are different, have different acidity in them. Household ammonia 12. Drain cleaner 14. Really, really strong base. Quiz time. Which is the strongest acid? Okay, so I know A comes before B, and I know that 7 is in the middle. So I know that my acids, if it's going to be an acid, it's got to be less than 7. So I'm going to cross, oops, I don't know what just happened there. I'm going to cross out 9, and I'm going to cross out 13. Okay, so the stronger acid is not going to be close to 7. It's going to be over here. So that would be number pH 2, which is A. The weakest base. Okay, so now we're on bases. So I know, again, I'm going to draw my thing out again. Here's 7. A, B, C, D. Okay, so the bases are over here at greater than 7. So that means I might as well cross out my acids. Goodbye, goodbye. So these two things are bases. So now the trick is figuring out which one's the weaker base. Anything close to 7 is close to neutral, so that's the weaker one. So that would be 9. The strongest base would be 13. The weakest acid is going to be close to 7, but under it, which would be 6.
Didn't know we could do that.
It's true. And that's the end of chemistry.